We now want to continue on our discussion about making conversions between one unit and another, but now we want to look at problems that involve what are called compound units, so making conversions involving compound units. So what is a compound unit, you may be asking? So it is a unit that is composed of more than one unit. So for example, meters squared, so for area, that's the unit of area, or possible unit for area, so we would take length times width to give us meters squared, and then just ignore what looks like the British spelling of these words. So this table must have had British origins, but despite the spelling, I like this table. And then volume is length times width times height. So we have, if we're using the SI unit of length, the meter, so meter times meter times meter. Velocity and speed, so distance per second, so speed is equal to distance over time. So we have both a distance unit and a time unit. So that's a compound unit, so like miles per hour or meters per second. And so here we have a distance unit and a time unit. And density is also a compound unit. So we have mass divided by volume. So we have a unit of mass and a unit of volume involved. So all of these include more than one unit. And so let's say we're given a problem like this. So the average speed of a nitrogen molecule in air at 25 degrees Celsius is 515 meters per second. Convert this speed to miles per hour. And so we have meters, so that's distance. So speed is equal to distance over time, so meters, and we want to convert that to miles. And we have seconds, which we want to convert to hours. And so if you just remember top and bottom cancel out, you're good to go. But how we would write this or express this is 515 meters per second, so per means over or to divide by. So 515 meters per second. So that's how we write that. And then we need conversion factors to go between meters and miles, and then between seconds and hours. And so you may want to find that conversion table from from the previous slides. So that will give you the conversion factors that you need. So find that table and then work through the problem and come back. But you have to first convert, or well, it doesn't matter which one you convert first, but you have to make the conversion from meters to miles and then from seconds to hours. Okay, so I found a copy of my conversion table, which I should have included, but I can go from kilometers to miles, so I can go from meters to km to miles, and then for the seconds to hours, I can go from seconds to minutes to hours, or if I know how many seconds there are in an hour, I could also use that. So there are 60 seconds and 1 minute, and then 60 minutes in 1 hour, or there are 3,600 seconds in 1 hour. So you can go step by step or go straight from seconds to hours. Okay, so I want to go from meters to km, and you may have used a different set of conversion factors. That's fine. It just may have an impact on sig figs, so depending on the conversion factors that you used. So let's first go from meters to kilometers or kilometers. So I know that there are 1,000 meters per 1 km. And so now meters cancel out. I'm in kilometers per second, essentially. So if I divide it by 1,000, I would have kilometers per second. So now let's go miles per second. So then 1.609 km is equal to 1 mile. And so now we have miles per second if I were to divide by the 1.609. So 515 times 1 divided by 1,000 times 1 divided by 1.609. So I would essentially have miles per second. But I want miles per hour. So the next or final step is I could use my conversion factor, 3,600 seconds per 1 hour. But notice this time seconds is on the bottom, so that has to cancel out with this on top. So top and bottom cancel each other out. So now I have units of miles per hour. So I plug all that, multiply, divide, multiply, divide, multiply, divide, or if you want to multiply across and then multiply across and divide them at the end, that's also fine. Another thing, yeah, that probably won't let me erase. You could have done an extra conversion. You could have said 60 seconds per 1 minute. So if you wanted to go from seconds to minutes and then minutes to hours, you could have also done that. But that's the same. So 60 times 60 would give you 3,600. And then how many sig figs? So inexact, exact, inexact, and then this is exact. So 3. So either 1,150 miles per hour, or to eliminate ambiguity, 1.5 times 10 to the third miles per hour. Okay, and then an example involving volume, so length times width times height. So let's say we wanted to go from inches cubed to centimeters cubed. So we have our regular conversion factor to go from inches to centimeters. But if we have inches cubed, then I need to transform my conversion factor. And so I would need to cube this entire thing such that it becomes 2.54 raised to the third and centimeters raised to the third, inches raised to the third to give us inches cubed. So that would allow inches cubed to cancel out. So when a unit is raised to a power, the corresponding conversion factor must also be raised to that power in order for the units to cancel appropriately. So an adult has 5.2 liters of blood. What is this amount in cubic meters? So 5.2 liters, and we have this relationship. 1 liter is equal to 1 decimeter cubed. So let's start there first. So 5.2 liters, and then we have 1 liter is equal to 1. Okay, and so then pause the video and make sure you can get from decimeters cubed to cubic meters or meters cubed. Okay, so we want to go to meters cubed, so we need to know the relationship between decimeters and meters. So King Henry died by drinking chocolate milk. Kilohectodecabase, deci, centimilli. So there are 10 decimeters. So 1 meter is equal to 10 decimeters. So 1 meter is equal to 10 decimeters. So you can use that as a conversion factor. So 1 meter, 10 decimeters. But I have decimeters cubed, so I have to modify my conversion factor appropriately to give me decimeters cubed. So what I do is I cube this entire thing. So then it would be 10 raised to the third power, and then decimeters raised to the third power give us decimeter cubed, and then meters cubed. And so then, so we plug that into our calculator. And so essentially 10 raised to the third is 1,000. So we'll be dividing by 1,000 here. So your answer should be 5.2 times 10 to the negative third meters cubed. So 2 sig figs. And then 71.2 centimeters cubed to meters cubed. So again, 1 meter is equal to 100 centimeters. So 1 meter is equal to 100 cm. So 1 meter, 100 centimeters, but we have to change this appropriately. And so then this gives us 7.12 times 10 to the negative fifth meters cubed. Okay, more practice. So an automobile tire has a pressure of 32 pounds per square inch. So pounds per square inch squared. So what is this pressure expressed in grams per centimeter squared? Okay, so pause, or square centimeter. So pause the video. Oh, and then maybe before that. And then the other one, the density of propane is 36.28 pounds per cubic feet, or feet cubed. Convert this to kilograms per meters cubed, or cubic meters. Okay, so pause the video, work through these two problems, then come back. Okay, so I would write this as 32 pounds per square inch. And then, so I essentially want to go from pounds, unit of mass, to grams, and then then I want to go from inches cubed to cm, or not, sorry, squared. Inches squared to centimeters squared. So 32 pounds per inch squared. So let's go from pounds to grams first. And we're given this conversion factor. So 454 grams per 1 pound. And then we have canceled pounds. Now we have grams per inch squared. And then let's do the final step, inch squared to centimeter squared. So 1 inch is equal to 2.54 centimeters. And so notice again, this will allow top and bottom to cancel out, and I need to square this. And so then this should be equal to about 2.3 times 10 to the third centimeters squared. Okay, and then 36.28 pounds feet cubed. So then let's go from pounds to kilograms. So pounds to kilograms. So I'll go from pounds to, and it's good to write out your strategy. So pounds to grams, then to kilograms. And then we want to go from feet cubed to inches cubed, and then we can go to from inches to centimeters cubed, and then we can go from meters cubed or centimeters cubed to meters cubed. So we know how to get from feet to inches, inches to centimeters, centimeters to meters. Okay, so let's go from pounds to grams. How do we do that? So we have grams per 1 pound. So we have now grams per feet cubed. Then we want kilograms. So then 1 kilogram is equal to 1,000 grams. I'm going to need more lines. So see, these get pretty lengthy really quickly. And then I have 1, so I'm going to go from feet cubed to inches cubed. So 1 foot. And then 1 foot is equal to 12 inches cubed. So now feet cubed cancel out. I currently in kilograms per inches cubed. And then I go a step further. So we're going to go from inches cubed to centimeters cubed. So 1 inch, 2.54 centimeters. You have to cube that so that inches cubed cancels out. And then we have 100 cm, 1 meter cubed. And so I'll be left with meters cubed, so kilograms per meters cubed, which is what I wanted. And then so this should be about 582 kilograms per meters cubed. Okay, that was a fun problem. Okay, but just top and bottom cancel out. That's all there is to it. And then so far we've only converted from one unit of a given measure to another unit of the same measure, such as from length to length, or time to time. However, we also have conversion factors that can convert from one measure to a different one. So even though we changed the distance or changed the mass and changed the volume here, we went from one mass unit to another one, and then also from another volume to a different volume unit. But now we want to use conversion factors that will allow us to convert from one unit to another. So for example, density can be used as a conversion factor to relate the mass and the volume. So remember, density is equal to mass divided by volume. So if I multiply the volume by the density, I go to mass. Or if I divide the mass by the density, then I go to volume. So density has mass component and a volume component, so that's a compound unit. So I can express this as 3.8 grams per milliliter, or 1 milliliter gives us 3.8 grams, or 3.8 grams per milliliter. So I could use that as a conversion factor. So you see, if I have the volume in mils, if I multiply by the density, mils cancel out, I'm left with grams. Or if I have the grams, essentially divide by, so if I have the grams, divide by the density. So I'm dividing by that value of density. So mass divided by the density, and I'm left with units of volume. So we're going to use density as a conversion factor. So 3.8 grams per mil or 3.8 grams per mil. So depending upon what I'm trying to cancel out. Oops. Okay, so what is the mass in grams of 1 gallon of water? The density of water is 1 gram per milliliter. So I want to get the mass using the density and the volume. So density is equal to mass divided by volume. So I know essentially if I want the mass, I have to say the density times the volume. But in order for the milliliter part of it to cancel out, I need my volume expressed in the same quantity. So to get the volume part of density in milliliters here to cancel out, I need the volume in milliliters also, so that when I multiply, they will cancel out. So the only way they'll cancel out if they are the same unit. So if I had gallons here and milliliters here, then those won't cancel. Essentially volume, so convert the volume to milliliters and then times the density, and that gives us the mass. It would give us the mass in grams, and then pause the video, work through this problem. So I'll set it up. So I'll start with the volume, convert that to milliliters. So we have 1.0 gallons of water. So now take it from there. So go from gallons to ultimately milliliters. And then once you have your volume in milliliters, you can multiply that by the density. But again, grams per mil or mil per 1 gram. Okay, so your turn. So pause the video, work through it, come back. Okay, so then I have to go from gallons to milliliters. First go through liters. So 1 gallon is equal to 3.78 liters. And then 1 liter is equal to 1000 ml. So now I have my volume in milliliters. And then if I times it by the density, so which one of these do you want? So this one, because it allows top and bottom to cancel out. So 1 gram per milliliter. So gallons cancel out, liters cancel out, milliliters cancel out. I'm left with units of mass in grams. Okay, so plugging that into my handy dandy calculator. Oops, which just dropped. I got 3,780 grams, or to eliminate ambiguity, 3.78 times 10 to the third grams. And then if it was kilograms, then you could have gone another step and divided by 1,000. And then let's see a note about significant figures as it relates to temperature. So the conversions between Celsius, Fahrenheit, and Kelvin temperatures are exact. So this means that the fractions 5/9 or 9/5 and the number 32 are exact. The number 273.15 in the Celsius to Kelvin temperature conversion is also exact. And so let's look at an example in terms of sig figs. So the temperature of a metal is 4.483 Kelvin. Convert this temperature to degrees Celsius. So we would have to subtract 273 from the Kelvin temperature. But since this is exact, we ignore this, and since we're subtracting, but it'll be based on the number of decimal places in our original value, since this is an exact value. So then we should have 3 decimal places based on the rule of subtraction in terms of decimal places. And then if you're doing multiple steps, so if you, let's say you were doing step by step instead of dimensional analysis, but like I said, dimensional analysis is preferred. Don't try not to round. So like I would write out the entire number, try not to round for intermediate steps, because then by the end you've introduced a lot of rounding error. So when a calculation involves 2 or more steps and you write answers for intermediate steps, retain at least one non-significant digit for the intermediate answers. This will ensure that small errors from rounding at each step do not combine to affect the final result. When using a calculator, you should carry all the extra digits through until you obtain the final answer, and then determine the number of significant figures at the end. So try to consider significant figures only at the end, not for intermediate steps.